You're going to have a power pack, which looks like this on a circuit diagram, and connected to the power pack, you're going to take one wire out and connect to an ammeter. An ammeter is a circle with an A in the middle. From the ammeter, you're going to connect in series a heater, which looks like 4 rectangles connected to each other as thus, and then you're going to finish the series circuit and connect it back to the power pack. Then you're going to take a voltmeter and piggyback across to measure potential difference across your heater, and you'll use a voltmeter, and the circuit symbol is a V like this, and that's the circuit diagram. Here is the equipment that you're going to need to be able to use. We've got a ammeter, which looks like this, a voltmeter, which looks like this, and the circuit diagram for your ammeter and voltmeter here and here. And we've also got our heater here as shown, which is this one with the 4 rectangles. We've got our 5 leads, which are the straight lines, and you've got your power pack, which is shown here. There's this orange bit equipment here, which is shown over here. Now we've also got 2 other things. We've got a thermometer and the 1 kilogram aluminium sphere, which we're going to work out the specific heat capacity of, which is also there as well. This is how you set up the equipment, like that it is shown in the circuit diagram that we just drew. So if you take your ammeter and you lay it out next to your power pack, and then you have your voltmeter as well, and you set it up like this. So our ammeter comes first, and then if you put your voltmeter next to your cylinder that you want to measure the specific capacity across, you can then connect the wires however you would like according to the diagram. If you connect from the direct current from the power point into the ammeter, from the ammeter into the heater, from the heater back into the other end of the direct current on the power pack, and then piggyback your leads from on top of those wires to our voltmeter. And in doing so, what you'll be able to do is measure the current and the potential difference and the temperature as you're going along. In your table of results, as shown, what you need to have is a column for time, you have a column for current, I in amps, a column for potential difference in voltage, V, change in energy, which you'll be able to calculate using potential difference times by current times by time, and change in temperature, which you will need to have the final temperature taking away the initial temperature that you start with. So you'll need to note down that as well. Fill your table of results in as you go along. Right, now you need to put a graph where you have the x-axis the change in energy and the y-axis is the change in temperature. And then what you need to do next is have the gradient, which is the change in temperature over the change in energy. Now, because of the equation, the specific heat capacity is going to be 1 divided by the mass times by the gradient.